Hey, Mr. P, I just read that 60% of Rochester residents say that winter is their favorite season.
No way! That's way too high.
Don't just talk smart, Mr. Math Teacher. Go ahead and prove it.
Fine, well, I'll go out and take a simple random sample of Rochester residents, go door to door, collect some data, and we'll see what I can find. Hi, ma'am. I'm doing a research project. Can you tell me, is winter your favorite season?
Absolutely. I'm just headed down to the rink now. When else am I gonna play? Hello?
Hi there. I'm doing a research project, and I was curious if winter is your favorite season.
Heck no. I pretend that it's summer all year round.
Ma'am, I'm doing a survey on whether or not winter is your favorite season. I suppose if it is, can you sit for me? No? I just have to call you non-response. I went out and I collected my data and I found that only 15 out of 34 people think winter is their favorite season. And that means that that's only 44%, which is way less than 60%. So I'm right.
Your survey was random, right?
I'm a stats teacher. Of course it was random.
How do you know you didn't look out and just ask people that don't like winter?
That's very possible. I could have randomly chose people that just don't like winter. However, there's only a 4.5% chance that I found the results I did if we assume the null is true. Let me explain. Let's start out with the default assumption that that news article was right. 60% of people really do like winter in Rochester. Let's pretend that's true. Well, I think it's less. So I went out and I collected my data. And then I created a sampling distribution using StatKey. Let me show you. We're looking at StatKey's randomization test for a proportion. I started out by entering my original sample data, my 15 out of 34, which is about 44% as a proportion of the population that I'm estimating. My default assumption is that it was actually going to be 60%, so that's going to be in the middle. That is the null or starting hypothesis. Now I'm going to generate multiple resamples, a bootstrap distribution, just like I would with a confidence interval, so I can see what are the different possibilities. Could be as low as 35% or as high as 85%, but most of the time it's going to be around my null hypothesis that's actually shifted to the middle here. So now let's go ahead and say I want to find the probability it's as low as what I found. So I'm going to shift down here to the left tail. And because there's some rounding error with StatKey, I'm going to switch this to counts. And I'm going to change the low end count for the left tail to the 15 out of 34. So I'm going to change it to 15. And when I do that, it's going to tell me the probability of finding the results I found. And as I refine this a little bit, that number might slightly change, but it's going to come out to approximately 4.5%, 0.044. That 0.044 is my p-value. It's the probability of finding results as low or lower than I did when we assume that the null hypothesis, the 60%, is true. That's how I'm convinced that I am in fact right.
Wow, I'm so glad I married a stats teacher.